right, so this is the cylinder we're going to break right here. This is the concrete cylinder. I made it back in early 2020. I made it in early 2020, right before COVID. So I made it for my class, but then we never had the chance to test it because they kicked us all out. So it's been waiting for about 5 years now to get broken. It's pink because I put dye in it. So we're going to break it right here in the universal testing machine. We're going to put it right here on the loading deck. This is the loading deck. So you remember from lab number 1 and lab number 3 that the specimen was placed up here, wasn't it? And so if you want to test something in tension, you put it up here. If you want to test something in compression, you put it here on the loading deck. So that's where I'm going to put this specimen. Now I've got these load caps that I'm going to put on the top and on the bottom. So I'm going to put this load cap, see the load cap? I'm going to put the cylinder in the load cap. Why do I do that? Why do I have to put load caps on this cylinder? Why can't I just put the cylinder in here, right on the loading deck, and crush it as is? Why do I have to put load caps? Yes, sir?
To disperse it evenly?
Yeah, to spread the loading out more evenly, because inside the loading cap I've got this, what looks like a rubber pad. If I were to look at this cylinder under the microscope, if I were to look at the top and the bottom of this under the microscope, I see little hills and valleys. So by putting the load caps on there, it's helping to distribute the load evenly over the top and the bottom. So I'm going to put the load cap, I'm going to put load caps on either end of this cylinder, okay, like this. Okay, so now it's in the bottom load cap, and now I'm going to put it into the machine. Okay, so I'm going to put it here on the loading deck. Okay, how does that look? I put the specimen there on the loading deck. And I have to put the top loading cap on there. So this is the top loading cap. I'm going to put that on top. And there's a rubber pad inside of this one also. So I'm going to put this on top like so. Okay, now what do I do? Well, I have to bring the crosshead down. I'm going to bring the crosshead down. So to do that, how do I do that? I have to turn on the electricity to the machine. So over here is the on-off lever. I'm turning it on. I'm going to bring the crosshead down. So these buttons control the crosshead. So I'm going to bring this down. And I want to leave a little bit of daylight between the top of the specimen and the bottom of the crosshead. Okay, so far so good. You see the protective cover that's on the threads here? It's covering the threads because I don't want to get pieces of concrete tangled up in the thread. So that's why our lab tech Greg put that cover on there, is to keep the scraps from getting into the screw threads. Okay, so I'm going to bring this down a little bit more. And it would actually be beneficial to put a spacer in there. So I'm going to put another pad on top of the specimen, on top of the upper load cap. Okay, like that. So I put an extra spacer in there. Okay, so I'm going to fire up the software. So if you get a close-up of this here, I'm going to go to MTestW right here. I already turned on the controller. I turned on the controller. If I don't turn on the controller first, then the software does not fire up. So the first thing I have to do is float the table. Okay, before I float the table, I'm going to move the crosshead up just a little bit. I probably should not have moved it down so much. So I'm moving it up because I want to have a little bit of space in here. When I float the table, the loading deck is going to move up a little bit. So I have to allow for that by having a certain margin there between the top of the specimen and the crosshead. Okay, so now I'm going to open up the software that floats the table. Okay, so 1, 2, 3, 4, 7. Okay. Okay, so it's go to 0.5 inches. So right here, I click open. Okay. Okay, what am I missing? What do I have to do here? I have to turn on the hydraulic pump. Okay, I'm going to turn on the hydraulic pump. So I opened up the file that will float the table. So now I'm going to turn on the hydraulic pump by pressing this green button. Okay, so I'm going to float the table. I'm going to float the table. First I tear it, that means zero it out. And then I press play or start. Actually, I think it's called resume. Play or resume. Okay, so now the table is floated. The table is sufficiently floated and the specimen is in place. Okay, I'm going to bring the crosshead down to close this gap. See the gap between the top of the specimen and the bottom of the crosshead? I'm going to close that, but I want to leave a little bit of daylight in there. Leave a little bit of daylight. You see, I want to kind of close, I shouldn't put my fingers in there. I want to close this gap, but leave a little bit of daylight. So what I propose here is lowering the crosshead. Lowering the crosshead until I kind of sort of close that gap. Can you see over my shoulder? I think that's good enough. Yeah, I leave a little bit of daylight there. Okay, so I'm now going to open up the test that controls the. I'm going to open up the file that controls the test that we're going to use. So, madam, if you could get a close-up of this. So it's right here. And I actually programmed this. It says 302 concrete compression test right here. So I open this up. I'll hold the camera myself when it gets excited. Okay, so right here, I open up the proper file. And if I go up here to test, and then test setup, I can see the various parameters here, like under servo profile, it's telling me the rate that it's going to load. It's only going to move 1 inch. The loading deck is only going to come up 1 inch as per the way that I programmed it. Data acquisition, servo profile. I've got all the parameters necessary right here. Okay, so is everything in place? Am I missing anything? Boy, I sure am. I'm going to put this shield up. Okay, so I'm going to put this shield around the back. Are you catching this?
Yep.
I'm going to put this shield on the back like so. And then I'm going to put this other shield on the front. Why? Well, I don't want to get hit by flying concrete, so that's why I'm putting the shield up here. Okay, like this. How do you like that? Our lab tech Greg made that. He did a good job making this shield. So this will kind of protect us. A little bit of it might come out the top, but still, it protects us for the most part. Okay, so now I put the protective shield around it. Isn't that something? Okay, so everything is in place, so now I'm going to start the test. So I tear it, T-A-R-E, tear, and then press play. Okay, I'm going to be right in front of it. I'll get down so that you can see this. Can you see with me in the way? I'll get down even lower. How much load is on the specimen now? 190? You can see over my head, can't you? Okay. I should have brought in a tripod. You see the load versus displacement diagram being traced out on the screen? What kind of failure? I forgot to go over the kinds of failure that you might witness. I should have done that upstairs. There's different types of failure modes. Yeah, I'll talk about it on Wednesday. What are we up to now? Do you know what part of the machine is moving? So much for that. It'll stop after it moves an inch. You see how the load dropped here on the screen? Oh, caramba. What kind of failure is that? See the big vertical cracks there? Am I in the way? It should stop after an inch. Little ways to go. I'm at 0.6. I don't think it'll break much further. I can let it go a little bit farther. Can you see over my head? What was the peak load? You look at the screen, what did it tell you? 86,191 pounds. I'm going to write that on the board in just a moment here. Can you see over my head? This is going to be a Discovery Channel quality video. It should stop after 1 inch. I'm waiting for it to get to 1 inch. But it's not going to take any more load. You see how it flatlines here? How it flatlines on the screen? A little bit farther. And that's it. See, it stopped at 1 inch. It stopped at 1 inch. Okay, so now I'm going to take a close-up of this, and there you go. So I go up here to test, and then save, and then I'm going to save this desktop under CV302, and then I have to save it as a RAW file, RAW, and then what is the date today? The 28th? July 28th. I'll say July 28th cylinder. July 28th cylinder, and then I click save, and that should do it. After closing the file, close the file to shut off the hydraulic pump, and then to turn off the controller. I'll come around the back. Watch your step. So that turns off the controller, and then shut off the electricity to the machine. Well, I pulled the data off of the computer as a RAW file, and then I open it as an Excel file. So this is what the data looks like as an Excel file. I cleaned it up a little bit. So as I can see here, the maximum load that the cylinder took was 86,191 pounds. So I graphed the load versus the position, that's machine position. The columns strain 1 and strain 2 are both 0 because there was no extensometer attached to the specimen. There was no sort of device to measure the displacement of the specimen itself. So these columns would just be 0. So the graph that I'm going to show you is load versus machine position. The maximum load was 86,191. So the 86,191, where is that exactly? So I'm going to go to find, and then 86,191. So it looks like that's row 810, row 810. So 86,191 pounds, that was the maximum load sustained by this specimen. Okay, so I graphed the load versus machine position, and that would be this here. I looked in my records, that cylinder that was tested that you just saw, I created it back on March 10th, 2020. So that was right before COVID. So on March 10, 2020, so that cylinder was a little over 5 years old. So this is what the graph looks like. The x-axis is displacement. The x-axis is displacement, machine displacement. The y-axis is load in pounds. So that peak, what did I say the peak was? 86,191. So it looks as though that's about here. See where the cursor is? 86,191. So after the cylinder reached a peak, there was a sudden drop because of catastrophic breakage. But then it managed to pick up some more load, followed by another catastrophic breakage. And the way that the software is set up, the way that I programmed it,
the loading deck should stop moving after 1 inch, and that's what we see here. The loading deck stops moving after 1 inch. So you see that here along the x-axis. So this is the graph that tells us where the peaks were, and it tells us the displacement. So there you have it.